Hello students, let's go to next topic about syllabus, that is nothing but a vertical circular motion. So before going into detail of this, first of all, let's see what exactly vertical circular motion. The motion in which particles revolve in a vertical circle is said to be vertical circular motion. If you remember, in last part we have learned the conical pendulum which is moving in horizontal circle. So that is horizontal circular motion of conical pendulum. Here it is exactly opposite. It is vertical circular motion, means particle is moving vertically. For example, when suppose just imagine this is watch. I know that this is not, let us imagine this is watch. Just we have just put it on the wall. Now here hands of this watch are moving, okay, clockwise direction like this. Hands are moving means what? Tip of the hand, let us assume the particle was kept on tip of second hand. So what will occur? As second hand will move, the tip is also moving. So that tip is performing what? Vertical circular motion. If I have just taken a watch, keep it like this, it is vertical. If I just rotate it like this is a watch now. I have put on my hands. The wall watch I have put on my hand, then it becomes what? Horizontal circular motion. So we are interested here in a fact that here watch is attached to the wall, so the hands are moving vertically. So we can say they are performing vertical circular motion that we want to consider here. So this is one of the basic example for this. Now let's go further. As before going in detail of this topic, let us consider particle having a mass m. Suppose some particle is there whose mass is m. Here the particle having a mass m, rotating in a vertical circle in anti-clockwise direction like this. Just see these arrows. It is moving in anti-clockwise direction along a circumference of a circle. Then it is said to be particle is performing vertical circular motion. Now within this circular curve or within this circumference there are 4 points. This point A, suppose this is the point A, that is said to be this point A is the highest point of vertical circular motion. The point B at the bottom here, lowest point of the vertical circular motion. Point C and D are the moderate point where it is not at a higher point, it is not at a lower point, it is exactly in between higher and lower, exactly in between. And this circular path has a radius of r. Particle has a mass m. When particle is at point A, it has a velocity va. When particle is at point C, velocity vc suppose. At B, it is vb. Similarly, at D, it becomes vd suppose. And this particle, let us imagine, it is tied to the string, inextensible massless string. We have tied that particle and just we have hold in our hand and just we are rotating like this. Okay. Instead of hands of the clock, we have taken a string, massless inextensible string. To other end of the string, we have attached what? The heavy mass or particle. Now we are whirl it in a vertical circle. Now the bob or that particle is moving in vertical circle and we want to determine that motion of that particle, and we have to find out under this topic what is the velocity at highest point, what is the velocity of same particle when it reaches to lowest point, what is the velocity at this moderate point during the vertical circular motion, that we want to find out. I hope that you got what we want to find out. Now let's go. As particle has mass m and due to gravity, this force mg is always directed in downward direction. Remember, at position A, mg directed in downward direction. Apart from this, there is another force that is said to be tension in the string, that is Ta. Tension in the string when particle is at position A. It is always act toward the origin. When it is at A, if it is at B, still it is always act toward the origin B. Origin O. So this TV is going toward the origin. At this place, mass due to gravity, it is going in downward direction. Tension going toward the origin. Opposite direction these are. Here they are in same direction. Both are coming in downward direction. Now let's start with the point A first. So we will derive some condition for point A. I will write it here. For point A. For point A, or it is said to be highest point. Highest point. So at point A, or it is said to be highest point. Now what we want to determine? Our aim is to determine what? Our aim is to determine the velocity when particle is at higher point. So before going into detail, let's see. As particle perform a circular motion, there must be what? Centripetal force. and that centripetal force is always directed toward the origin of the circle along the radius. So these two, mg and ta, both are moving toward the origin. So here necessary centripetal force for this circular motion is provided itself by these two things. So we can write this one equation for this. So we can write here ta plus mg, as both of them are moving in same direction. We can write ta plus mg, and these are responsible for vertical circular motion here, or circular motion. So they will provide necessary centripetal force, that is mv square by r, and it is velocity at a, so it is mva square by r. Let us suppose equation 1. So I hope you got this equation 1. Just these two forces are responsible. They will provide the necessary centripetal force required for circular motion. So we have written this equation 1 accordingly. Now in this case, as particle comes at a highest point, its velocity is minimum. Velocity is minimum, or we can say the tension in the string would be minimum. Tension in the string is minimum. Let us suppose the tension at the highest point is Ta, and suppose this Ta is 0, because it must be minimum, so that string should not slack. So it is suppose highest point, the tension in the string Ta is 0. Just put that value here. You can write the equation as this. Equation implies that mg equal to mva square divided by r. This m from this side, this m from this side, cancel it out. Move this r to this side. What we get? Va square equal to rg. This implies that Va equal to square root of rg. In this fashion, we have find the value of velocity Va. It is what? Square root of r into g. The velocity at highest point, square root of rg, we have find out by putting the value of tension in the string as a 0 here, and just solve it for Va, cancel the mass, we get this equation. And that is nothing but what? Velocity at highest point when particle perform a circular motion. Now let's go to the lowest point B. Then we'll go to the moderate one. Let's go to lowest point. When particle move from A to B, what is occurring? Height of particle decreases at A as compared to B. The point at A, its height is what? R plus R, that is diameter, twice R, at a height of twice R. When come at B, what can occur? Suppose it is ground level, the height would becomes what? 0. R would be 0 here. Just imagine, highest point, this is the lowest point, ground level. When particle is at point A, it is at a height of twice R from B. At a height of twice R from B. When particle comes at B, what is the height? 0. So what is occurring here? Height changes, and as we know, the potential energy would be given by m into g into h. This h is very important because that h is responsible for what? Change in potential energy. So at point A, h is more, potential energy is more. At point B, h is 0 or less, we can say. So the potential energy would be less. Now what will occur with the kinetic energy? As we know, the total energy is always constant. So this, when particle move from point A to B, potential energy decreases. At the same time, its kinetic energy get increased. Means what? Potential energy converted into kinetic energy. Decrease in potential energy is equal to increase in its kinetic energy. This concept we are going to use here. Before going to use this concept, just first of all, we have to write some equation as we have written like this. So yes, I will put it here. Second part I will write here. So let's go according to that second part I will write. So second, for point B, or it is said to be lowest point. So let us derive some condition. As already we have learned here, mass is always act in downward direction because of gravity. Mg is going downward. TB is always directed toward the origin as they are moving in opposite direction, but still these two forces are there. So these two forces, TB and mg, are responsible for circular motion here at a position B, and they will provide a necessary centripetal force at point B. So we can write simple equation, that is TB, it is moving toward the origin, minus mg, it is moving in downward direction. As they are moving in opposite, so minus sign we have taken. As they are moving in the same direction, so here we have taken a plus. Okay, added together, here subtracted together. Equal to what? mv square divided by r, and this velocity at b, so it is m into vb square divided by r. So this we get second equation for the position point B, lowest position. We get this as a second equation. Now let's see what is the change in potential energy. We can write here change in potential energy must be equal to, or loss in potential energy must be equal to gain in kinetic energy. Loss in potential energy must be equal to gain in kinetic energy. So what is the loss in potential energy when it is moved from this to this? What is the initial potential energy? Loss we are mentioning, but actually it is coming toward B, so it is loss. Potential energy lose when it comes to the B, so the loss in potential energy. So initially when particle is at A, what is the potential energy? Its potential energy is what? We can say it is mgh. So I will write here m into g into h, potential energy. Kinetic energy. So when particle come toward the B, what will occur? Its kinetic energy get increased. So that we can represent by equation 1 by 2 mv square. That is equation for kinetic energy. So we can write here equal to gain in kinetic energy 1 by 2 m into b square, kinetic energy at B, minus 1 by 2 m into va square. This is nothing but what? Gain in kinetic energy. Vb, kinetic energy at B, minus kinetic energy at A. That is change in kinetic energy, and that must be equal to the change in potential energy. Now what is h here? In between A and B, what is the distance between the point A and B? It is r plus r. It is twice r. So we can write it here mg into twice r. Same thing they have mentioned in their book. Mg into twice r equal to 1 by 2 m into vb square minus 1 by 2 m into va square. Multiply both sides of this equation by 2. Just multiply 2. What we get here? Or we can do one thing. Just this m from this side, m from all this side cancelled out. Okay. Multiply both sides by 2. What we get here? 4. This 2 into 2, 4 rg or gr equal to vb square minus va square. 4, see, just multiply by 2. 2 into 2, 4. 2 cancelled out. 2 cancelled out. Mass throughout we have cancelled out. So we get this equation 4 rg equal to vb square minus va square. Now what is the value of va square? We have written here. Square root of rg is va. Its square is what? Simply rg. Put it here. So we can write this equation implies that, I will write it here, 4rg equal to vb square minus rg, because va square is rg. Now move this rg to this side. It is minus, it goes here, it becomes plus. So what we get? Directly I will write here. Move this rg to this side. 4rg plus rg, it is 5rg vb square equal to, so vb equal to square root of 5r into g. In this fashion, we have determined the value of vb here. We have determined the value of vb here. So 4 plus 1, it is 5rg. This 4rg plus this 1rg go to that side, become plus 5rg. So vb equal to square root of 5rg. Why it is square root now? Because here it is square. Find out the value of vb, it comes in square root. Root of 5rg. So we get this value at velocity of particle. When it comes at point B, its velocity is root 5rg. At A, its velocity is rg. What does it mean? Particle is moving with a variable velocity. At point A, velocity is this. At point B, velocity is this. At point C and D, velocity would be different. So that means particle is moving with the different velocities along the circumference of vertical circle. Now remember, point C and D are such that they are at equal horizontal height. So that velocity, whatever be the velocity of C, that must be equal to velocity of D. Both of their velocity is same. Why? Because both have same height. Is that clear? That's why their velocity is same. But what would be the direction? Direction is opposite. It is going up, it is going down. Direction is opposite, but magnitude is same. at point C and D because they are at a equal height. Now let's go. Apart from the same thing, just we have to write a little bit different point of the same. This topic is not ended here. Little bit one equation we have to write further. Let's start with that equation. I will put my mobile down little bit here and I will write that equation. So what we have to do here we have to do is what? Just we have seen this diagram here. Okay, we have seen this diagram here. In this diagram, just we have find out velocity at A, velocity at B. Suppose I want to find a tension at the difference in the tension at B and A. I want to find out. How can we find out? Just we have written two equations. Equation 1 for highest point, equation 2 for lowest point. Add equation 1 and 2. What we get, that we'll write. Add equation 1 and 2, and whatever we get, that result we will write, and accordingly we get one equation here. So add equation 1 with equation 2. What we get? Just instead of adding, just subtract them, because we want difference in the tension TB and TA. Difference we want. So don't add, subtract them. So what we get, I will write it here at the top. Do you got it? Yes. You are getting, na? Yes, fine. So here we can write TB minus TA. Subtract the two equation 1 and 2. Or 2 minus 1. Equation 2 minus equation 1. TB minus mg minus TA minus mg. So I have taken first TB minus TA minus mg, and minus mg becomes minus twice mg. Minus twice mg. That is the left hand side. Let's go to right hand side now. What is that right hand side? See, m by r is common, so we can take it common. M divided by r in the bracket VB square minus VA square. VB square minus VA square. So that equation we get, that is change in the tension. If we move this mg to that side and put the value of VB square and VA square, just see, VB square is what? VB square, just we have written here 5rg. VA square is what? Rg. 5rg minus rg is 4rg. 4rg plus this twice mg. Okay, 4rg plus twice mg. So we can write this as equal to 4rg into m by r as it is. M by r as it is. This r cancel with this r. We get here. What do we get here? No, just wait. So we will write it further. Okay. So here we get TB minus TA minus twice mg equal to m by r VB square minus VA square. If we solve it further, what we get? TB minus TA. Directly I will write here. TB minus TA equal to 6 mg. How it will get? Just do one homework to all of you. It is better to give homework sometime. So let's put the value of VB square as square root of 5rg. Put the value of VA square. It is square root of rg. Square is rg. Square root is 5rg. Put it here. Move this term to this side. We get this equation. Because this cancel, r get cancelled out here. Suppose I will write here like this. M by r as it is. 5rg minus rg. It is 4 of rg. This r cancel with this r. It becomes 4 mg plus 2 mg. It becomes 6 mg. So the difference in the tension at lowest point and highest point, that is TB minus TA. Difference in the tension of lowest point and highest point, TB minus TA, is 6 mg. Is that clear? Difference in the tension would be 6 mg, lowest and highest point. That you have to remember. Sometime lot of time they have asked this. Show that in vertical circular motion, show that tension in the lowest point and highest point, difference in the tension at lowest and highest point is 6 mg. Show it that. So we have to derive this equation 1, 2. Okay, we have to derive this already formulas. Square root of rg, square root of 5rg, then equation 2 minus 1, just write it here, then we get here it is TB minus TA as 6 mg. Apart from this, similar to this second parameter, similar for point B, we have to determine now equation for velocity of particle performing circular motion at point C and D that we have to determine. So let's start with the equation at point C. So I will write here third topic for point C or D, or it is said to be moderate point. At moderate point, what is the velocity of particle that we have to determine here? Moderate point, what is the velocity of particle that we have to determine here? So from this again same diagram we can write here from the diagram, just look at this diagram. So we can write here Tc minus Ta equal to Td minus Ta. Why so? Because both are at equal height. So we can write like this. Same thing they have done in your book. Just I will write according to the book. Tc minus Ta equal to Td minus Ta. Td minus Ta. That same thing they have just written in your book. And this is equal to thrice of mg. And this both must be equal to thrice of mg. Now the question comes how? It's very simple thing. As we know, here we have written the Vc equal to Vd because they are at the same point, same height we can say. Vc equal to Vd, same height. And tension in the string at point A is 0. So see, Tc minus 0 equal to Td minus 0. It is what? It is what? Tc minus 0 equal to Td minus 0. Why it's come to be thrice mg then? Because initially we have find out difference in the tension at B and A is what? 6 mg. Exactly at the center here it would be thrice mg. In between A and B or B and A it is 6. Exactly at the middle it is thrice mg. So that is nothing but what? Difference in the tension at moderate point and highest point. Tc minus Ta or Td minus Ta, moderate to highest, and that is nothing but a thrice mg. I hope you got this. So in this fashion we have find out this tension at point C and D. It comes to be thrice mg. Now the question comes. Suppose some question get asked in board examination. What is difference in the tension between B and D or B and C? What is the value? It must be thrice mg. 3 plus 3, 6. So here it is 3 and here 6 minus 3. It is what? Is it 6 minus 3? So 6 mg. But for A it is 6 mg. For D if you want to find out, what is that? It must be 0. Because thrice mg and here it is thrice mg. It will be 0. So let's go further. We have to determine velocity. Va, we have determined Va, we have determined Vb, now we have to determine Vc. Now how can we determine? Again same formula. As particle move from A to C, here its potential energy decreases and it results into increase in kinetic energy. Now what is the potential energy? So we can write one equation here, mgh equal, this is the potential energy. Decrease in potential energy result into increase in kinetic energy. 1 by 2 mvc square minus 1 by 2 mva square. This equation for C we can write. If you consider D, you should use here D. So that can be written later on. So h, what is height from the point C? It is perpendicular distance is r. So we can put here it is r. Initially we have put it as twice r because A and B separated by twice r, A and C separated by simple r. So we can write this equation. Now here again m from all sides get cancelled out, multiply by 2. So twice rg equal to Vc square minus Va square. What is Va? Va is square root of Rg. So it is minus Rg. Vc square minus Rg equal to twice Rg. Move this Rg to that side. What do we get? Vc square equal to twice Rg plus Rg, thrice Rg, or Vc equal to square root of thrice Rg. So we can write this as Vc equal to root of thrice Rg and same Vd equal to root of thrice Rg. In this fashion, we have find out the velocity at highest point, velocity at lowest point, velocity at moderate point. Apart from this, what we have find out? Change in the tension in the string when particle at B and A 6 mg. Change in the tension in the string when it is at C and A, that is nothing but a thrice mg. That topic we have finished now. Now the question comes, in your book they have taken a case 2. So on next page, 11 number page, remember this, you just go through this topic, page number 11, you have to go, just read it, try to remember that topics. Let's go to case 2. What is the case 2 they have mentioned? Here we have assumed that the particle is attached to the string or thread, massless, inextensible thread or string. That's why it has a tension TA, TB and so on. But remember, suppose I have replaced the string by rod. Just we have attached the particle to the rod and just move it in vertical circular motion. What are the changes that we have to learn here? So see, same thing they have mentioned here, that is the case 2. In that case, there should not be upper value of some tension. It may be 0, it may not be 0. So 0 speed is possible at uppermost point they have mentioned. So velocity may be 0 at highest point. If we replace the string by the rod, so the rod does not require the tension, so velocity at highest point A may be 0 in that case. If that velocity is 0, means what is there? VA equal to 0 for rod. If VA equal to 0 for rod, what should be the remaining things get changed? That we have to see here. So what the remaining things? If we replace the string by the rod, the highest point velocity may be 0. Or it doesn't have a tension, then highest point may be 0. Now let's see here, according to this, just we can determine velocity at lowest point. This is the velocity at highest point for rod. This is for rod. Velocity at lowest point VB. This is VB for what? Rod we want to determine. Now see, we have written one equation here. VB square minus VA square equal to RG. Just look at example. VB square minus VA square equal to 4RG. Just look, I will just move mobile here. Just this equation. VB square minus VA square equal to 4RG. I will write this equation here further and then we'll go further. So I will write it here. VB square minus VA square equal to 4RG. We get this equation. And as this is for string, but in case of rod, VA is already 0, we have mentioned here. So if this is 0, we can write here VB square equal to 4RG. VB equal to 2 root of RG. And this is the velocity at a lowest point VB with a rod. So we can write this VB as 2 root of RG. Remember, VA is 0, VB is 2 root of RG. What is change in the tension? T lowermost minus T uppermost remains same. It is 6 mg. Basically, rod doesn't have tension, but when we wield it, there is no change in tension, but there would be change in the velocities. That is nothing but this topic. In this fashion, we have completed the vertical circular motion. Just do one thing, watch the video. While watching the video, put a book in front of you, then you understand it well. I hope you got it. If you have any problem, you can contact. Thank you.